So I've written about the importance of brain plasticity and how crucial it is for students themselves, besides educators and parents, to know that the brain is malleable, even through adulthood. Many believe that mental capacity is fixed. You're either born smart or not. And this is such a misconception. So it is fundamental for students, educators, and parents to know what there is behind the notion of brain plasticity. How does active learning and play impact brain plasticity? How does this come about?
Okay, so there's a lot of questions within this question, but the first thing I'd want to say is I 100% agree with you about how fundamental understanding the plasticity of the brain is, and how it is kind of emotionally, morally, and scientifically wrong to say that things are fixed, that anything is fixed, because the brain remains plastic right the way through life. And by that, I mean from the womb right through into old age. And the reason it does is because plasticity is evolution's way of allowing brains to adapt to the bodies and environments that they find themselves in. It's an absolutely key part of how we have evolved. And I think, I mean, just to be explicit about it, what plasticity is the process by which the connections between neurons, which are the key part of any sort of thought process, it's the process by which those connections are changed in response to some kind of stimulation from the environment. And when you think of it that way, I mean, there's a lot of things that are kind of written popularly in the UK, at least, about, you know, you must keep doing your Sudokus or your crosswords, because you're essentially adding stimulation from the environment to change the connectivity between neurons to keep the possibility of new connections, changed connections, and activity in the brain. And it's thanks to that plasticity that people can recover from even really dramatic types of brain damage, because the brain can change connections in the non-damaged area in response to that. And another thing I think, that even though often we think about, or we talk popularly about plasticity in terms of those same kind of thinking processes, plasticity is a feature of all kinds of learning, like whether it's playing the piano, whether it's kicking a football, whether it's learning a language, or remembering what happened yesterday. That's all plasticity. So it covers a huge amount of different things, and without it, we wouldn't be able to form any new memories. So I think, even though, I mean, it's something that is a feature of the brain through its whole lifespan, but it's not constant. And plasticity can be reduced because of stress, because of injury, because of aging, and it can be increased by certain other activities, like by getting enough sleep, by exercise, and by learning itself. So you can get into a sort of virtuous plasticity circle. And I think, well, one thing that I think that you were getting at to do with, so there's sort of what plasticity is, and then there's students or learners understanding about plasticity, which in itself is a really powerful learning tool. And one thing that I think is particularly interesting that relates to that is what happens in adolescence, because I think what we know from the last sort of couple of decades of neuroscience research is that our kind of old view, our kind of 20th century view of brains was that lots and lots develops in the early years, and then by about kind of 12, secondary school age, the brain's done, and it's sort of like an adult brain, and then it just carries on. And what we've learned is that that is really wrong, and there's huge brain changes that happen throughout the whole of adolescence. And obviously adolescence doesn't have a set number of years of age to define it, but that means going right the way through off until the early 20s. And the exciting thing about that age is that not only is there all of this plasticity and change, but the people who are experiencing it are old enough and articulate enough about themselves to understand what it is that's going on and use it to their advantage. And I think this is another really key thing that educational neuroscience has sort of pushed on, is what we call metacognition. So that's thinking about thinking and learning about your own learning. It's not kind of treating a group of 30 students in the classroom as all the same. It's thinking of those 30 people as 30 brains with slightly different operating systems that they can learn about themselves, and having learned about themselves can kind of optimize to their own needs. So I think that there's a kind of specific thing. I think it's great for all children, all learners, to understand about plasticity, but there's a really powerful way of harnessing that knowledge for slightly older children and adolescents who have the capability to sort of to have that kind of extra layer of thinking about how they think and learn. There's a lot more that I could say about that, but I'm going to be disciplined and put a full stop in there.
This is a very interesting part of education neuroscience, and I think teachers, educators, and students need to be aware about brain plasticity. Brain imaging studies have also shown that when we observe others carrying out actions, mirror neurons fire as if we are carrying out the actions ourselves. This helps explain why teachers' gestures can enhance memory. Can you elaborate on this?
Yes, absolutely. So I think, well, there's a funny thing about mirror neurons, because I think mirror neurons were one of those things that were a bit the kind of, when they were first discovered, there were so many people who were so excited about them, and so much research exploded out that there was a lot of hope almost pinned on them, as if mirror neurons were going to be the answer to everything, from autism to empathy to everything. So I'm going to slightly rein back on the fact that gestures are important because of mirror neurons specifically, although that absolutely is a part of it. I think that why gestures can enhance memory and learning is because all learning benefits from happening in multiple modes. So actually what you're doing, if you're gesturing at the same time as you're explaining something verbally and having something written on the board, is you're giving many opportunities for the brain to experience the same knowledge from slightly different entry points. And I think gestures, that's great. And gestures will utilize mirror neurons for that. But actually, even if we're not specifically talking about gestures, that idea of learning benefiting from getting the information from multiple different sources applies very, very broadly across learning. Because if we think of something, there's an example that we give in the book, which is, if you think of something as simple as the number 6, right? The number 6 is it's a concept that feels so obvious to us that we don't think about what it is. It just feels like, how could you not know that information? But what it takes for the brain to build up a concept of the number 6 is many, many exposures to slightly different variations of the number 6 that allow it to kind of pull out the common themes in that and form a concept, which then can have, usually has a language label like 6 attached to it, and that helps it be kind of like held. But actually getting to that point requires, it takes quite a long time to get to that point. And if you think of all of the different experiences a young child might have, it's to do with counting on their fingers, it's to do with hearing the words in a song, it's to do with seeing a cluster of 6 items. It's knowing that actually if you had 6 of something and one gets taken away, it's not the same thing again. There's a lot of quite complicated things that what the brain is trying to do is sort of lay them all on top of each other and find what's the thing that connects all of these things, and that's the number 6. And so and that benefits from, that's kind of links to your question, I think, about gestures, in that yes, gestures, yes, visuals, yes, audio input, yes, touching and feeling and playing with objects with our hands. The more different senses that we can engage in getting to those concepts, the better they're going to be. And also the more entry points there are when we're trying to remember things about them, because just as how those concepts are formed, how they can be retrieved can be via any of those sensory pathways.
I believe in multisensory teaching and learning, especially within the early years. You know, I think it's so vital. Enhancing creativity and imagination skills in students is one thing I believe strongly in. I just mentioned it. Encouraging students to wear their thinking hat and use their critical thinking skills, where they look for flaws in dubious reasoning, is one thing we need to improve on here in our educational system locally. Are there neuroscience findings supporting the importance of divergent thinking strategies and creativity in general, or personalization, that is creating a link between the content and the student's personal life, or critical thinking aimed at improving mental flexibility?
So my PhD was all about children's creativity. So this is an area very close to my heart. And I also spent, before going into educational neuroscience, I spent 20 years or so as a creative producer in the TV industry, making science programs and developing ideas. So creativity is kind of my heartland. And increasingly, I think, you know, because we do see creativity along with critical thinking, which you also mentioned, and collaboration and communication as key 21st century skills. In theory, I don't think that we're anywhere near, I mean, at least speaking for the UK, I don't think we're anywhere near seeing those kind of skills prioritized in schools. And I think that there are conflicts inherent in the approaches of a lot of education systems. I'm afraid I don't know a lot specifically about Malta, but certainly in the UK, the education system is about passing set exams, and that's quite difficult to meld with really creative approaches, because creativity doesn't necessarily fit into a neat exam box with right and wrong answers. It unfolds on a slightly unpredictable time frame compared with other kinds of thinking. I think people are still slightly afraid of it, or they think it's a bit fluffy or woolly because it can't be boxed. So I think that there are many issues. I think there's a lot of people, and certainly I think a lot of teachers, who hunger for more scope to be creative in their classrooms, but they're limited by the system in which they're operating. From a neuroscience, to answer your kind of neuroscience question, I think there's some very interesting evidence that is starting to come out about how the brain does creativity. So one experiment that I think is interesting was a neuroimaging study of jazz musicians, which is quite a thing to picture if you imagine an MRI scanner with a jazz musician inside playing a specially adapted keyboard. And what they were looking at was what were the brain differences between when the musician was just playing set prescriptive composed pieces of work compared to when they were improvising, which improvising being a sort of shorthand for being creative in the musical domain. And what they found was that actually when they were improvising, there were certain parts of the brain that were kind of dampened down, turned down, if you like, to allow them to improvise. And the parts that were damped down were what we call the kind of executive control system. They're the parts that would be on fire when you're doing a school exam, right? So they're the kind of logical, procedural, planning, inhibiting irrelevant things, paying attention, staying focused. But actually what that study suggested was that when you want to be slightly freer to improvise, those parts might need to take a bit of a back seat. So I think that creativity is a really active area of neuroscience research at the moment. And I think, you know, I really hope that over the next years we'll come to some, you know, more findings of that nature, which give respect to the fact that there might be different ways of thinking that are suitable for creativity, as opposed to other sorts of thinking that you might want to test in schools. And for me, I think you mentioned the word flexibility. For me, and what I found in my PhD was that creativity is all about flexibility, because any creative process involves a certain amount of very controlled types of thinking and another set of thinking processes which are much more spontaneous. They're about surprising connections. They might be about finding remote connections between things. They might be about making analogies. They might be about input from different kinds of senses than you might usually use. And if we think there's an old model of creativity, which I think still holds a lot of water, which talks about the stages of creativity, where the first stage is kind of it's problem investigation, if you like. So it's kind of like mapping out what is it we're trying to work on here. Let me try and find the boundaries of what the creative problem I'm trying to solve are. And then there's an incubation stage when you might not be actively working on the problem, but it's still kind of mulling away in the back of your mind. And then there's the third stage is illumination, which is that kind of like, I've got it, you know, that aha moment where something just slightly changes shape that means that you can see a way forward. And then the last stage is verification, which is when you challenge and test that new piece of sort of understanding that has arisen quite spontaneously. And if you think about it in those stages, the first and the last are quite controlled, they're quite procedural, they're quite, you know, challenge and test. Whereas the middle phases are much looser. They're much more about being open to possibility. They're about maybe sometimes not having your focus set on that particular thing, but being free to explore it while you're out on a walk, or, you know, it's allowing time for that to evolve. But you need all of those different kinds of thinking, which is why flexibility is key, because you've got to be flexible enough to allow for those different processes, ideally to recognize when might be the time to apply one type of thinking rather than another type of thinking. Like, you know, most creatives know there's a moment when you've got to step away from the problem. That's the only way that you're going to make progress on it, is to move away. So I think that flexibility and ideally the metacognition to sort of see and understand the thinking processes are also really important for creativity.
Thank you. In view of the above, how can we ensure that neuroscience findings transform into pedagogy, and how can we make sure that this happens?
So I think there are gradual changes. So in the UK, there's some new parts of the teacher training syllabus where trainee teachers are taught more about memory and different types of memory, and that teaching is trying to get across the idea that memory isn't a store cupboard that sits somewhere waiting to be opened, but that it's you know, memory is essentially a reactivation of all of the same neurons and connections that were activated when the memory was formed. So it's super active. It's like, it's about the brain being fully engaged. It's not about a hunt to some distant cupboard. So I think that there are some changes that are happening. And similarly, I think there's more and more of an understanding about the importance of metacognition. I think that's something that is now on the radar of, I mean, I'm not saying that's entirely come about through neuroscience findings, but I think that that has helped. And I think the other thing, it's kind of more sort of, how do systems change? I don't think we should think of this as there's a bunch of neuroscientists over here who are going to sort of sprinkle their knowledge over on teachers who are over here, because that's never going to work. Firstly, teachers are having people tell them what to do all of the time. And if I was a teacher, I think I'd be completely fed up with it. So it's more about how do we form a kind of collaborative enterprise where teachers and neuroscientists are working together so that teachers understand what's useful for them to know about the brain, and neuroscientists understand what teachers want to know for the classroom. Because I think sometimes there's a real misalignment, because what might be really interesting for the purposes of scientific research is sort of some passing interest to teachers, but they're not the stuff that they're really concerned about. So I think the answer to how do we ensure that those findings transform into pedagogy, I think we talk. It's about dialogue, it's about collaboration, it's about openness. It's not about one group of people telling another group of people things. It's about a consortium of people who care about how children learn, working together to maximize that.
Thank you, Cathy, for this insightful information about the different areas, in education and neuroscience, and hope that you'll be our guest once again in the future once the book is published.
Thank you so much for having me. And yes, I'd be delighted to come back and talk more.